Hey, and welcome to today's video where we're going to talk about how we use trigonometry to actually solve for some of the angles. So in the last video we did an introduction. We talked about what is sine, cosine, and tangent. How do we get these ratios? But now we're going to actually talk about how to solve for the side lengths and the angle measurements using these ratios. So again, key things that I want to touch on. These rules only apply to right triangles. Really important there. So don't try to apply these to like some obtuse triangle or anything like that, only right triangles. And also memorize SOHCAHTOA, because this helps us be able to know these ratios without just straight memorization. We can just kind of write this down on the top of a quiz, a test, SOHCAHTOA, and that will help us realize that. Remember that each letter stands for one of these ratios. So it's sine, and then the O and the H stand for opposite and hypotenuse. Then C stands for cosine, and then adjacent over hypotenuse. So SOHCAHTOA to help you memorize that. And now let's just get into it. And also here, consider yourself standing at the reference angle. So the side across from you would be the opposite, and the other side would be the adjacent. So kind of the side that's next to you. You know the hypotenuse, so the best way for me to figure out the adjacent is it's not opposite me and it's not the hypotenuse. That must be the adjacent side. And so now let's really get into some of these tougher problems and find out why we've been doing this trigonometry. So solve for x. So this is a perfect example of what trigonometry helps us do. How can I solve for x if I'm given this angle and I'm also given the hypotenuse, right? Because that is the longest side. It's the side opposite the right angle. So 16 is the hypotenuse. And now let's think, okay, so obviously I'm given this angle, so theta has to be 35. So theta is going to be 35 degrees. And I don't know this side, so I don't know the opposite side, right? Because that's opposite the angle. But I'm looking for x and I'm given the hypotenuse. So what you need to be thinking about is what trigonometric ratio relates the adjacent and the hypotenuse. That's going to be cosine, right? Because it's SOHCAH, C-A-H. So it's cosine of theta equals adjacent over hypotenuse. And I knew that I had to use that because those are the two angles that I have the two sides that I have something to do with. I have the hypotenuse and I'm looking for the adjacent. Okay, and I also have the angle measurement. So now I'm just going to plug in what I have and try to solve for that third side. So I'm going to get cosine of 35 equals adjacent. Well, that is x in this case, divided by 16. Okay, now cosine of 35, you have to type this into a calculator. There's no key here to memorize that. Make sure you are in degree mode on your calculator, and then just hit the sine button, cosine button actually. Cosine of 35, I got 0.819. And know that that's just plugged into calculator. So with trig, you're gonna have to definitely have a calculator, and make sure it's in degree mode. So plugged into calculator. Okay, so now we have 0.81915, something like that, equals x divided by 16. How do I get x by itself? Multiply both sides by 16, and I'll do that in my calculator as well. So times 16. I'm left with 13.11 approximately. So x equals 13.11. So that means the side length is 13.11, and that makes sense in terms of the problem. I agree with that, and I feel like that's a good answer. Okay, so that is how we actually use trig. So hopefully that's starting to really make more sense than what we did in the last time, where we were just taking the ratios. Now you're seeing what we actually use these ratios for. It's to help us solve for triangle measurements. All right, so we have two more here. This one is going to be a little bit different from the last one. Remember the last one, our goal was to solve for a side. Now we're solving for the measurement of the angle. So, and now again, we need to think about, well, what are we given? Are we given the adjacent, the hypotenuse, the opposite, which ones? And I see that we are given the opposite, right? And then we're also given the hypotenuse because that's opposite the right angle. So I'm given opposite and hypotenuse. What trig function relates those two? That's going to be sine, SOHCAHTOA. So S-O-A, S-O-H, so opposite over hypotenuse. And that's going to be sine of theta, or sine of x here, equals opposite over hypotenuse. And we are given the opposite and the hypotenuse. So I'm going to put sine of x, because that's the measurement I don't know. That's my variable this time, equals 20 divided by 25. And now this is a little bit different because normally you would think, okay, well, to get x by itself, I can divide by sine or something, because usually when we have something in front of x, we divide by what's in front of it, and that gets x by itself. But we can't do that here. Sine of x is one variable. You can't just divide it away and get x by itself. So what we do is we have to take the inverse. And the reason why that makes sense, let's think if we have 5x equals 25. I know most of you are going to say, well, we can just divide by 5, right? Well, of course we can, but we can also multiply by the inverse, which is 1/5. That would also get the same thing where x gets by itself. So x equals 25 over 5, or 5. And so what we did there is we multiplied by the inverse, and that's what we need to do with trig functions. So it's similar to dividing, but it's not the exact same, and it's what we have to do for trig. So what we do is we take both sides. Let me give myself a little bit more space here so you really see what I'm doing. And you're going to have to do this next part in your calculator, but I want to help you reason why we are doing it. So we're going to take sine inverse, and it's written by, you write the trig function and then you just put a little -1 in the front, in the top of it. So sine inverse of sine of x, and then multiply, and then we also need to do the sine inverse of this side, because if what we do to one side, we have to do the other. Then what happens is the sine inverse and the sine cancel, and we're left with x equals, then you write it as sine inverse of 20 over 25. And that's going to be our answer, and this is something you plug into your calculator. There's actually going to be a button for that as well. So this plug into calculator, there's usually the button associated with sine. Above it will say sine to the -1, and that is the sine inverse. So you usually have to hit second and then the sine button, and you'll get sine inverse. And then you do 20 divided by 25. Make sure you're still in degree mode, and I get 53.13. So x equals 53.13, and I want you to think for a second, well, what measurement is that? Is that in centimeters? Is that an angle measurement, or what? And that's a degree measurement, because that is, remember, we were solving for the angle measurement the whole time. So that is an angle measurement. X is 53.13 degrees. Hopefully that makes sense. If you didn't get that same answer, I recommend you go back and rewatch what I did here. I know this can be tough, especially if it's the first time using your calculator to do these problems. So we take sine inverse to get rid of the sine, and then we have to do the sine inverse of the number that's left over here. Okay, so let's look at one more. Alright, so here we have a rectangle, and it says solve for the measure of angle ADB. So the first thing I'm going to do is write what that angle is, like what does it look like, what one arm am I solving for. ADB is right here. I'm going to label that theta. Okay, so how do I figure out angle ADB? Well, I know I'm going to use trig because this is a right triangle, right? That's right there. But how do I figure this out? Because I'm given the hypotenuse, I'm going to draw just the ADB triangle, because I'm a little confused with the whole rectangle here. So I'm going to have this, that's the triangle that I have, and I'm looking for theta. I know that this is the right triangle, and I actually know the hypotenuse too. This midline, this diagonal, is 22, and that's going to be my hypotenuse. But the thing is, I don't know my opposite side, I don't know this side, and I also don't know my adjacent. Well, it's not labeled clearly, AD is not labeled, but I am given, I actually do know the adjacent side because of this is congruent to this, and that's what these dashes here represent. These dashes on the sides, that tells me that they are congruent. So I know that this is 12. Well, then I know this is 12 too, and now this is a trig problem that I can solve, right? Because now I see I'm given the adjacent side, because it's not the opposite side, it's not the hypotenuse. I'm given the adjacent, and I'm also given the hypotenuse. And what trig function relates the adjacent to the hypotenuse? Well, that's cosine again. So cosine of theta equals adjacent over hypotenuse is 12 divided by 22. And now here again, this is good practice. Now how do we get cosine by itself? We take the cosine inverse of both sides. So this is cosine inverse. And now that these cancel, and we're left with theta equals, and then remember you have to write cosine inverse of 12 divided by 22. And again, this is something you have to type into your calculator, cosine inverse of 12 divided by 22, put in calc. And again, it's going to be this, you're going to hit the second button, and you're probably going to have to hit the cosine button, and then that should give you cosine inverse, and then you do 12 divided by 22, and I get 56.94. So I get theta equals 56.94. And I'm going to write that that equals the measure of angle, because that's what they wanted, measure of angle ADB. I just labeled it theta to make it a little easier, but it is the measure of angle ADB. So hopefully now, this is a really important video. I recommend you have to come back to it a few times over the course. Maybe if you just need a refresher on trig, how do we use trig to help us solve for triangles, things like that. Hopefully now you really understand and memorize SOHCAHTOA. That's probably one of the most important things in the entire course for geometry. Just memorize those ratios, and you should be good to go. And don't hesitate to contact me with any questions. I know this can be a tough topic. So have a good one.